Let's start with the next question. Question number 7 of exercise 6.5. So it is given in the question that we have to prove the sum of the square of the sides of a rhombus. So ABCD is given a rhombus where AC and BD are diagonals, and we have to prove that sum of all the square of sides of this rhombus is equals to sum of the square of its diagonals. Students, we know one property of a rhombus, that in a rhombus diagonals bisect each other at right angle. So let's show here that point O is the intersecting point of diagonals. So here let's write down that in rhombus diagonals bisect at 90 degree. So here this property will use to prove this, the required. So here we can say that the diagonals AC and BD of ABCD intersect at point O. So we can say that angle O must be right angle. So if you observe this diagram very carefully, so you can see that AOB is form a right angle, same BOC, COD and AOD. So let us go for that. Now for triangle AOB, as I mentioned, angle O is right angle. I'll use Pythagoras. So we know the Pythagoras theorem, square of the hypotenuse is equals to sum of the square of the other two sides. This is what I obtained. Let us continue with that. Now you can see in the diagram, similarly we can write triangle BOC, angle O is right angle. Again I'll use Pythagoras for the same. So I'll get BC square is equals to OB square plus OC square. This is the second number. For next, you can see here for triangle COD, for triangle COD, angle O is right angle. So again using Pythagoras, CD square is OC square plus OD square. This is equation 3. And for triangle AOD, again angle O is right angle. So Pythagoras AC is AD square is AO square plus OD square. As here in the proof we require sum of all this square of the sides as we obtain the fourth. So let's add all four equations. Add all four equations as we obtain 1, 2, 3 and 4. So look at the left hand side, that is AB square plus BC square plus CD square plus AD square is equals to OB square plus OC square, AO square plus OB square. You can see that OB square 2 times, OC square come 2 times, OD square come 2 times and AO square. That all we obtain 2 times, that is 2 times AO square plus OC square plus OD square plus OB square. But as we know that the diagonals bisect each other, that means AO is equals to OC and OB is equals to OD. So from here we'll substitute this value here. So we'll get AB square plus BC square plus CD square plus AD square. It's 2. AO square and OC square are same. So when I'll do the square, that means both are same. So 2 times AO square and this is written 2 times OB square. I'll take out 2 outside from both of this. So I'll get 2 is already there and 2. So AO square plus OB square. Now as we discussed earlier that the diagonals bisect each other. So we can say here the diagonals bisect each other. So we can say that AC, or we can say AO is half of AC and OB is half of BD. Let us substitute this value here in the above equation. So AB square plus BC square plus CD square plus AD square. As this 2 2s are 4, AO square is half AC square it should be whole square plus OB is half BD square. Let us simplify. I'll keep the left hand side as it is. 4 as it is. Half square, it's 1 by 4. So AC square by 4. And here again the same, BD square by 4. So you can see here that all this AB square plus BC square plus CD square plus AD square, that is the left hand side, is equals to this 4 AC square plus BD square upon 4. This 4 will come cut, so whatever we obtain here, that is the proof. AB square plus BC square plus CD square plus AD square is equals to AC square plus BD square. Hence we prove whatever we require. So I hope you understand this. It's quite easy. The same thing we have done 4 times and we added here. So thus we proved this question number 7. Let's continue with the question number 8 of this exercise 6.5. It is given into the question that point O is the interior of triangle ABC, where OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. And this is what we have to prove. So when we observe that, it looks very difficult and very complicated sums it looks like. But remember students, this is the question with relate with the Pythagoras theorem only. So let us do that. You can see here what we required, that is OA square. So what we will do, we will first join AO. So you can see here for triangle you can see that AOF angle F is right angle. So I'll use Pythagoras for this. So it comes as OA is the hypotenuse is equals to AF square plus OF square. I'll give this as an equation number 1. Now continue what we required. We will join OB. Here. Now I'll take this triangle, that is ODB or OBD, because here I required OB square and you observe the BD square is required here. So that is very important, that which triangle you are taking. So let's note it down. For triangle BOD, angle D is right angle. As angle D is right angle, so again I'll use the Pythagoras for the same. That is, as D is right angle, so OB square or BO square is OD square plus BD square. I'll give this as an equation number 2. One more, see, you can obtain OA square OB square, OA square OB square, AF square BD square, AF square and BD square. The rest of 2 are also we obtain here. Now one is left, that is C and OC. So obviously now we have to join OC. So for triangle OEC, we can see that angle E is right angle. So OC square, again using Pythagoras, is OE square plus CE square. This is an equation number 3. Now what we'll do, students, as you can see in the question, we required OA square plus OB square plus OC square. So we require the sum of all these three sides. Correct? And this AF square, BD square and CE square. So what we will do here, हम यहाँ पे क्या करेंगे, we will add all this equation. So let's note it down that add equation 1, 2 and 3. So OA square plus, I am adding the left hand side of equation 1, 2 and 3 is equals to, now all the right hand side, AF square plus OF square plus, you can see here from this, OD square plus BD square, and from this, that is OE square plus CE square. Now when we'll come to the question, हम जब questions की तरफ, मतलब the required OA square, OB square, OC square, all this 3, but OD square, OE square and OF square, which are on the right hand side, we should take all the terms towards the left hand side. All मतलब OF square ले जाएंगे, OD square which were required in the negative form, that all the terms will take towards the left hand side. So we obtain the first one. So OA square plus OB square plus OC square minus, you can write OD square minus OE square minus OF square is equals to, what remains here, that is AF square plus BD square plus CE square. So you can observe, students, that this is the first what we require the proof which we obtain. Hence we proved equation number, that means the first, not equation number 1. We have proved the first one. Now let's come to the second what we require. अब आप observe करो right hand side. This is what we require the left hand side of the second proof. मतलब इसको हम use करेंगे to prove the second proof करने के लिए हम ये यूज करेंगे. नाउ व्हाट वी रिक्वायर्ड, हमें AE चाहिए, CD चाहिए और BF चाहिए. ओके, नाउ लेट्स सी दिस ट्रायंगल अगेन फॉर ट्रायंगल AOE. For triangle AOE, we can see that angle E is right angle. So the Pythagoras, I'll just note it down here, that is AO square is OE square plus AE square. Fine. So what I'll do, I'll take this left hand side, so I'll obtain AO square minus OE square is equals to AE square. I'll give this as an equation number 5. Similarly, मुझे क्या चाहिए था, that I'll obtain here. AE square मुझे चाहिए था, मिल गया. अब मुझे चाहिए CD square. So you can see this triangle. I hope you are getting this. हमें AE चाहिए था तो मैंने ये ट्राइंगल लिया. अब मुझे CD चाहिए, so I'll take this triangle. For triangle ODC, angle D is right angle. Again I'll use Pythagoras, that OC square is equals to OD square plus CD square. अब मुझे what I required alone, that is CD. तो मैं CD अकेला रखूंगा. I'll take this left hand side. So OC square minus OD square is equals to CD square. This is the 6th number equation I obtained. One more is there. हमें दो मिल गए. That is AE square and CD square. Now what third is left? That is BF. So BF. तो कौन सा ट्राइंगल लेंगे? BOF. So for triangle BOF, which is right angle F, again we'll use Pythagoras. that OB square is equals to OF square plus BF square. हमें BF square अकेला चाहिए, so we should take this left hand side. So we will obtain OB square minus OF square is equals to BF square. This is the equation number 7 we obtain. Now what we require to prove? As we need to add all this, 5th, 6th and 7th. Now when you add this, now look at the question number 4. Equation 4 को अब हम कंपेयर करेंगे फ्रॉम इक्वेशन 4. हम OA स्क्वायर माइनस OE स्क्वायर दैट विल राइट डाउन टुगेदर. तो देखो दैट विल obtain equals to AE square. So from equation 4, what exactly we are doing? हम क्या कर रहे हैं? We are making a pair. हम OA square minus OE square को हम pair बनाएंगे. This one and this one. क्यों ऐसा pair बना रहा है? Because you can look at here. OA square minus OE square is AE square. This is the only reason I am making the pair. Now the second pair is OB square. मुझे OB square के साथ OF square चाहिए. And the third OC square minus OD square. So I am making the pair from equation 4, which is equals to right hand side AF square plus BD square plus CE square. Now for all these values which I have written into the bracket, you observe from equation 5, 6 and 7. OE square minus OE square, AO square minus OE square is AE square. Same way from 6 and 7. So we can write this value here. All the values from equation 5, 6 and 7, that is AE square plus CD square plus BF square is equals to AF square plus BD square plus CE square. This is all we obtain from equation 5, 6 and 7. Hence, we prove the required both the things, both the statement. So it's quite lengthy, but it is not so difficult. So that's all.